Yeah, welcome back. In this class, we are going to talk about the design rules for contact cuts. If you observe that we are having a contact in the stick diagram, when two different layers interact with each other, then we are having a contact. That is a general contact. But here, especially we are going to focus when polysilicon and diffusion, the two different layers, when interact with each other, we are having three different approaches for their representation. The first approach is oxide removal approach. The second approach is buried contact approach. And the third approach is butting contact approach. Is it clear? Now you can observe these three pictorial representation. First of all, observe this pictorial representation very clearly. Now we know very well that if we are having a substrate, let us consider this is our substrate. Now we know very well that this is your thin oxide, right? This is your thin oxide, and we know this is what poly and this is what diffusion. Okay, now you can observe this area. Okay, this area we are removing the oxide and we are making a contact between poly and a diffusion. Okay, with the help of what? Metal. Don't forget, with the help of metal, by removing what? Oxide. Is it clear? By removing oxide. That's why the first approach name is oxide removal approach. Now you can observe this second approach. Okay, this second approach, we are not removing any oxide here. You can observe very clearly, we are not removing any oxide. Just poly is coming over home diffusion. Is it clear? Poly coming over diffusion. You can observe in the depletion mode transistor very well. Okay, we have seen this type of thing in the depletion mode. This is poly. The poly is coming over home source. What is source? Diffusion. Is it clear? This is poly, and this contact I already said in the stick diagram. If you didn't watch it, please watch it. Okay, then this type of contact I already said. What is that contact? Buried contact. Here also you can observe that the second approach, the poly is coming over home diffusion. Here we are not removing any oxide, we are not using any metal. Is it understood? Now you can observe the third type of thing. You can observe what is the third approach. Can anybody try to tell? Okay, this approach, butting contact, is the approach. Now you can observe this third type. Can anybody try to tell what is happening there? Will you please tell me by observing the figure? Absolutely. Okay, what is happening? Okay, we are not removing any oxide. Okay, we are not giving a contact. That means poly is not coming over diffusion here. Here what is doing? We are connecting this poly and the diffusion with the help of metal. Okay, by external metal we are taking an external metal and we are connecting this poly and diffusion. This type of contact is known as what? Butting contact. Is it understood? Now will you please tell me, by observing these three figures, who is best for you? Absolutely. Why? Because oxide removal is best. Why? Because you can observe very clearly here. Okay, in the oxide removal you don't have any extra layer, okay, for giving a contact between poly and diffusion. Here you have to remove oxide, you have to use metal here. Is it clear? And here you have to use an extra metal, you have to give the connection between poly and diffusion. But here you can observe that just poly coming over diffusion, you do not use any metal, and it saves a lot of area. Therefore it is the best best approach among these three approach for giving the connection between poly and diffusion. Is it clear? Now once again I'm telling that, I'm recalling you, when the contact is going to be formed, when two different layers interact with each other, then contact is going to be formed. Is it clear? This is, let us assume this is one layer. What is that layer name? Metal is one layer and this is one layer. Can anybody try to tell what is this one? Yeah, absolutely, polysilicon. Then you are having a contact in the stick diagram. I hope that are you clear. Here in the layout you have to use what? Contact area and contact cut. I hope that are you clear. and you know very well what is present inside. Yeah, metal should be present. And the other layer, what is the other layer? You can observe polysilicon. This should be your contact. Okay, here you can observe very clearly. Now we will see after these three approaches. Once again I'm telling that oxide removal is the approach, buried contact is the approach, butting contact is the approach. These three approaches are especially used for what? Absolutely, for giving a contact between poly and diffusion. Now we will see some other rules of this contact. Okay, these are the approaches. We didn't see any rules, right? Now we can observe these three rules. Okay, now you can observe very clearly this one. Okay, this one we already know that when two different layers interact with each other, this is a metal one, this is what? Absolutely polysilicon. If these two are interacting with each other, then you are having a contact. I hope that are clear. Now you know very well the rules of what we'll call contact area. Contact area is what? 4 lambda by 4 lambda. If you want, you may observe this is 4 lambda. Here I mentioned this is 4 lambda, this is 4 lambda. What is the contact cut? 2 lambda by 2 lambda. Is it clear? This is 2 lambda, and here you can observe that this is what? 2 lambda, and this is what? 2 lambda. Therefore it is 2 lambda by 2 lambda. Here you may observe this contact area. This is 4 lambda, this is 4 lambda. I hope that are you clear. This is one type of representation. Is it understood? But this type of representation you can observe very clearly. Okay, this is one type of representation for giving contact. This is another type of representation for giving contact. Here if you observe that, okay, here there is a metal here and there is a polysilicon, but here there is a metal and here there is a polysilicon. I hope that are you clear. This is the rule, the basic rule. And shall we see the rule of buried contact and butting contact? Yeah, will you please observe here. Okay, now you can observe here multiple contacts. This is about multiple contacts. Okay, when two contacts are having side by side, before going to talk about the buried contact, you can observe this one. When there is two contacts, let us consider this is your entire metal, and you are having a polysilicon here, and you are having a polysilicon here. And if you are having a contact area, and if you are having a contact area, what is the minimum spacing between this multiple contacts? In essence, 2 lambda is the minimum spacing. If you observe that if you are having one more contact area here, okay, if you are having one more contact area, what is the minimum spacing between these two? Absolutely 2 lambda. This is the concept of what? Multiple contacts. I hope that are you clear. Okay, now you can observe the buried contact. Now you can observe this one, buried contact. You can observe this one. Okay, now this is very important. Why? Because especially in the depletion mode MOSFET, it is very regularly used. That means it is helpful in NMOS. You can observe that how this buried contact is going to be represented with a dash line, and it is a square, and it should be represented like this. I hope that are clear. In this way you can observe that. See, simply there is a polysilicon and there is a diffusion, then you are having a contact here. This is clear. This is a buried contact. Is it understood? Okay, now you can observe that once again I'm telling that when this buried contact will be available for you, absolutely only in which mode? Depletion mode transistor. I hope that are you clear. Okay, now you can see about butting contact. Yeah, you can see about this one, butting contact. We know that in butting contact we are not removing any oxide. Is it clear? We are not removing any oxide. Polysilicon is not coming over diffusion, and we are connecting poly and diffusion with the help of an external metal. You can observe that. Let us consider you are having a metal, this one, you are having a metal, and you are having a poly here, and you are having a diffusion. Now you can observe that you have to connect these two. Here you can observe that when metal is connected to what is that polysilicon, you are having a contact cut, okay, of 2 lambda. When metal is connected to diffusion, you are having a contact cut of what? 2 lambda. Is it clear or not? That means one more extra 2 lambda is present. Actually, what is the contact area? That is 4 lambda by 4 lambda. Is it clear or not? when one more what we'll call contact cut comes here, okay, then this length is going to be changed as 6 lambda. Is it understood? If you want, you may observe here. Okay, if you want, you may observe with this. Is it clear? You can observe very clearly with this. Now if you observe this figure, you can get a clear cut picture. This is for metal and poly, and this is for what? Metal and diffusion. Is it clear? Therefore the extra 2 lambda is there. Therefore you can talk about that is actually 4 lambda, but an extra 2 lambda is going to be present in picture, then it becomes what? 6 lambda. Now you can observe very clearly from this picture, you are not removing any oxide, and also poly is not coming over diffusion. You are using an external metal for making a contact between poly and diffusion. Is it clear? This type of contact is known as what contact? Butting contact. Butting contact. Is it clear? Now we can observe one more contact. What is that contact? Via contact. You can observe what is meant by via. Now you know very well this popular word. When you are traveling from one source to one destination, you are having so many vias. Let us consider an example. When you are traveling from let us consider when you are traveling from what we'll call some states. If you want, you may consider some states. Let us consider a state Andhra Pradesh to Telangana. That means let us take an example that Kadapa to Hyderabad. When you are traveling in between Kadapa to Hyderabad, you are having Kurnool, that is known as via for the destination from source. In this manner, here also we are having a concept which is known as via. You can observe this concept. Okay, this one you can observe very clearly. Okay, you can observe very clearly. Now here you may have a clear cut picture if you observe this. Okay, now with this figure it is very clear to you. Yeah, this one you can observe that very clearly. What is this one? Can anybody try to tell? That is metal 2. Is it clear? Now what is this one? Metal 1. Now what is this one? Absolutely. What is this? Polysilicon. That means very clear that you are making a contact. You are making a contact for metal 2 to poly, but you are using via. What is you are using? Metal 1 you are using as a via. Therefore don't forget how to represent via. This is the way to represent via. Is it clear? This is very important. Instead of contact cut, you have to use this one. This is the via contact. Contact area is same, but you can observe that contact cut is going to be represented like this. I hope that are you clear. Okay, that is an important point you have to talk about. If you want to see the other look, then you can observe this other look also. Is it understood? Okay, now you can observe this other look. Okay, clearly it is very clear to you. If you observe this other look, okay, you can observe this other look. This is metal 2. Okay, this is metal 1, right? And this is what? And either polysilicon if you talk about, or either diffusion if you talk about. Is it clear? Just you are observing, see, metal 2 is going to be connected with either diffusion or polysilicon. Okay, then you are having two contacts here. You can observe these two contacts. The first you may observe very clearly here is metal 2 to metal 1, and there is a via. That means metal 1 is via. Therefore in this contact cut you are having this symbol, and metal 1 is connected to either poly or diffusion, and it is a general contact. You should have a 4 lambda by 4 lambda, you should have a 2 lambda by 2 lambda contact cut. Here also don't forget, it is also 4 lambda by 4 lambda itself, but the way of representation of contact cut is different. It is going to be represented in this fashion. I hope that are you clear. That's it guys, this is about contact cuts. If you are having any doubts, you may ask. Once again, I'm just quickly recalling what we had discussed here. And the major issue is when two different layers are interact with each other, then we are having a contact. You can observe that the first topic we had discussed in this contact cuts is the three approaches. We are having three approaches for making a contact between polysilicon and diffusion. The first approach is oxide removal, the second one is buried contact, and the third one is butting contact. You may observe the clear cut picture of these three contact cuts for giving the connection between poly and diffusion. And after that, we have seen some rules here. The rule is the 4 lambda by 4 lambda is the contact area, 2 lambda by 2 lambda is the contact cut. It is a general one. When two different layers are interact with each other, then a contact is formed. And if you observe that a multiple contacts, when there are two or more multiple contacts, okay, then the minimum separation between one contact area to another contact area is what? 2 lambda. Is it understood? Now you may observe the approaches. Buried contact should be represented with this manner, and a butting contact, what is the main thing you have to remember in butting contact? Yeah, the length is going to be increased from 4 lambda to 6 lambda. Why? Because one more contact cut is going to be present. Now you can observe one more contact. What is that contact? Via contact. Okay, when you have to give the connection between metal 2 to some poly or metal 2 to diffusion, then you have to use a via. What is the via? Metal 1 is the via. Then this is a symbol how to represent via contact. Is it clear? This is one of the way to observe the via contact. Is it understood? Okay, if you are having any queries, you may ask. Thank you very much for each and everyone. In the next class, we will talk about CMOS lambda based design rules. Is it understood? Okay, thank you very much. Have a nice day. If you are having any queries, you can ask. Is it understood? Okay, thank you very much for each and everyone.